Now in number 1D, the first number is not repeated. I should actually not even have D in here anymore. But it's sort of, I keep it in there to show that I can go to something fancier, I can go to the basic method, and it depends on the restriction. And only with experience do I see which one do I use when. It'll naturally happen that you start realizing, no, I need to break this up more, or no, the basic approach is fine. How many ways can I fill the first position? 6. How many ways can I fill the next position? 5, because I can't repeat whatever this first one was. And then? 5. So often when I have the possibility of repeating something, a more basic argument might work. So the number of ways to do this, 6 times 5 to the 3, let's write it like that. So it's a mix of things we've done before. And the challenge is to know what to do when. That is a big challenge. And the only answer is to do examples. The only answer. The numbers are all distinct. So because we're just starting, I'm doing it for you. I want to do the stepwise strategy here again.
For D, sorry, could you write it as 6 choose 1 times 5 choose 3?
Let's see what it looks like. 6 choose 1.
Yeah,
I'm
times
definitely happy with that.
5 choose 3.
One step at a time. Is everyone happy with the 6 choose 1? I'm just choosing one number to go into position 1. Then I want to say 5 choose 3. Now it becomes important to know, what does that choosing thing represent? What am I doing? What am I doing when I say 5 choose 3?
You're like taking one spot.
She wants to fill the other 3 spots with that 5 choose 3. What am I doing when I say 5 choose 3? Forget about that specific example. Just in general, what does 5 choose 3 represent?
There's five choices where you're choosing. Number 3.
Okay, I know what you're saying. I just say it's slightly different.
Choosing 3 at once.
Choosing 3 at once. I have a bag of 5 things. I grab 3 of them. So when I'm saying something, choose something else, I'm always choosing them at the same time, which means they're going to be different. They're going to be different. Is there anything in the restriction that said that the other 3 numbers should be different? No. So I'm missing out. No restriction said that they should be different. So that's why I could say this: 5 choose 1, 5 choose 1, 5 choose 1. I have to do them sequentially so that I can have 5 choices every time. Yes?
Can you go 5 choose 1 to the power of 3?
Yeah, of course. Of course. It's just a number.
Yes.
You can do that. But there's a big difference between that and choosing them all at once. That's the important thing. So, if the numbers are all distinct, let's do them in 2 steps, like we did C. Let me write it in one line. Step 1 was what? Get the numbers together. So here's, let's say, select the numbers that will float in my cloud. For example, make a bigger cloud. They're just floating. I'm just selecting, making sure I satisfy the restriction. That the numbers are all different. Give me an example. 1 1, 2, 3, 4, 5. How many numbers am I selecting? Only 4. You got a little excited. Just kept going. That's okay. 1, 2, 3, 4. How many ways can I select 4 numbers? How many numbers do I have available?
6.
How many ways can I choose 4 of the 6 numbers? 6 choose 4. That's exactly what I need to do here. They need to be different. So in my bag of 6 numbers, I grab 4. These are just, I'm just conceptualizing. I don't actually have a bag of numbers. It's just how I can count an equivalent situation. Now I would need to arrange them. For example, I update my example here. I can get, let's be a little bit more original, 1, 3, 2, 4. I have 4 things. I want to arrange them. How many ways can I do that? They're all different. There's no identical elements or anything like that. There you go. I could have done, I could have done how many positions for the first one, or how many choices for the first position? 6, 5, 4, 3. This is the same. Same number in the end as 6 times 5 times 4 times 3. But it has a lot of benefits. Doing it this way is going to save you a lot of headache in the future. Doing this, I'm selecting and arranging in one go. I can't separate those 2 steps at all. And sometimes I could have restrictions that place some restrictions on what I could select and other restrictions on how I can arrange them. And I need to be able to separate these 2 steps in constructing my my result or my example. By separating them, I become much more versatile in handling a bunch of different restrictions. This one's very restrictive. It only does one thing. It selects and arrange. You can't separate those. So keep that in mind, that if I can separate them into smaller steps, if I can separate my experiment into smaller steps, then I can adapt to different restrictions much better. Okay, let's see what Timmy says. Timmy sequentially draws 4 marbles from a bag containing 3 red, 3 blue, 3 green, 3 yellow, 3 orange. They're all different sizes, so I can tell them all apart. They're all different. And then he places the selected marbles in a row as he draws them. How many different ways can this selection contain certain types of marbles and things like that? The first thing is I want marbles of every color in my selection. How many ways can Timmy do that? Or can I do that?
Do you see all different colors? Because there's 5 colors and there's 3 colors.
What does the question say?
It says every color, but you're only drawing 4 marbles and there's 5 different colors.
So you conclude?
Not possible.
She says not possible. No?
Unless marbles happen.
Everyone agree with her, or if you don't agree, then you have to be able to come up with an example of 4 marbles so that every color is represented. Not possible. I'm always going to miss one color. There's more colors than there are positions. Not possible. So, yes, you get excited about this choosing and factorial business, you just want to start writing stuff down. But the first step is to just think, how is this possible? Can I come up with an example? If I can, then it is possible, and let's figure out how to count it. If I can't come up with an example because it's not possible, then it can't be done. I can move on. How many ways can his selection have marbles of different colors? It doesn't have to be every color in my sequence, as long as they're different. Let's start focusing on this stepwise strategy. Very, very rarely do I need to do this basic strategy. Very rarely. Okay. You know, keep going. I like this board better. Let's do it on this board. So we're doing just little sort of play examples, but it's illustrating the thought process, the strategy behind these things. We're practicing problem solving in a way. So the actual Timmy drawing marbles situation is not really that important. Okay, what could a first step be? What is the question that you have first if I want to eventually have marbles of different colors? What would be helpful to know in terms of making an example? Let me say, you're making an example. You're coming up with your own example. What do you decide on first? There are 4 marbles. In the bag. There are 3, 3, 3, 3, so there are 50. That's all in the question. When I'm trying to make an example that has this restriction where I want to see marbles of different colors, which colors will appear? Which colors will appear? I have too many colors. Not all of them will be represented in this example. Which colors will appear? For example, which colors do you like? In no particular order. I'm just selecting colors. Red?
Blue.
Arrow green, I think. Orange. So yellow is clearly not a favorite. How many ways can I choose these colors? Note that I'm in no way finished. More steps need to come. I'm just choosing colors. I'm not even choosing marbles yet. But a marble is made up, and the name of a marble is made up out of the color and maybe a number. Maybe there's red 1, 2, and 3, blue 1, 2, and 3. Part of that marble is the color. How many ways can I choose 4 colors? How many colors do I have available? 5 colors? How many ways can I choose 4 up to 5 colors? I have 2 4. I'm making an example. How I do that systematically, I can do any way I want. I pretend I tear up a little piece of paper and I write red and blue and green and orange and yellow. Put them in a bag. I need to grab 4 of them to know which colors will appear in my selection. I'm just building an example. Timmy doesn't actually have to do this. He's not doing this. This is my way of thinking for systematically building the types of sequences that I'm interested in. So I only know which colors appear. I have no idea where they appear. So what is the next question? You don't have to do this in 2 steps. Might be more steps. What could be the next question? What do I arrange? Colors. I don't have any marbles yet. But I could arrange these colors in a row. And that at least tells me more about my outcome, my sequence. Arrange the colors. For example, so I'm getting closer to an actual sequence. I haven't arranged the marbles yet, I'm just arranging colors. For example, blue, green, red, orange. Many different examples. How many different arrangements can I get? 4? 4 factorial. There are 4 different things here, and I'm arranging them. Am I done? How do I know when I'm done? I'm updating my example, and I'm done when I have 4 specific marbles in a row. And I clearly don't have the marbles yet, I just have their colors. So I need another step. What is that step? I want to now choose the actual blue marble that goes in this blue spot. The actual green marble. Actual red and orange marble. Choose, let's say here, actual marbles. Let's update my example. Silly as it feels, it makes a big difference in knowing when to stop and knowing what to do, what to do next. Let's suppose I choose blue marble 1, then green marble 3, red marble 2, orange marble 1. How many ways can I do that? So technically, there are 4 steps inside this step, 4 little steps inside this step. By going along and selecting each marble, and actually doing something for it. How many ways can I choose the blue marble?
3.
That's right, 3, choose 1. But yes, 3. How many ways can I choose the next one? There are 3 green marbles, choose 3 of them. 1 of the 3 red, 1 of the 3 orange. Now, this step you can write in different ways. You can write 3 to the 4 if you want, but I'm emphasizing that I am choosing. Even when I'm choosing 1, there are different ways to write it. But it's best to leave it in detail and see how do I construct my answer. So in this case, there were 3 steps. But I do each one systematically. I have a running example, update my example, and see what do I still need to do, when am I done, and you can do the steps any way you want, as long as you're building up a valid sequence of marbles. Yes? Yellow isn't in our example because I eliminated him right from the start. But if someone else following the same steps, someone else could have a different selection of 4 colors here. Yellow might be his favorite color, so he goes with yellow. It's a different example. There are actually 5 different examples. 5 choose 4 is equal to 5. So depending on which one you start with, you just have an example and you update it to see what do I still need to do and so on. Someone else can start with a different example. Have a different arrangement here. So it might be different. This is just an example. Just an example. Not that simple. It's not that simple. But the first step is having me do it here and then trying to understand what's happening. So let's do C.
So what's the final answer? 5 choose 4.
That is the final
3, 1, 3, 1, 3, 1.
5 choose 4 times 4 factorial times 3 choose 1, 3 choose 1, 3 choose 1. It's all multiplied together. Because it was step 1 followed by step 2 followed by step 3, building up my sequence of marbles. I should multiply them all together. Notice how I'm not just writing the answer, I'm writing little explanations to show the marker, if it's a test question or a homework question, to show yourself when you look at this again a month from now. Where is this coming from? Oh, okay, I see. Much better. If we have the time, I encourage you to write little explanations or notes about what each step means. Okay, how much time do we have? We have some time. Zero. I only want to finish number 2. How many different ways can I get all 3 blue marbles? All 3 blue marbles. I want all 3 blue marbles, and I have a sequence of 4 marbles. What do you want to do first? Let's write it over here so I have some space. What do you feel strongly about doing first?
I don't know if this is what you're supposed to do first, but if you're going to have the 3 blues, then you're going to have 3 factorial to arrange the 3 blues, but also to select the 3 blues.
Okay, but what am I doing? Do you select or arrange? I don't want to do them in one go. So let's maybe select them first. The more steps, the smaller each step is, the safer it is. So what do you want to select? Blue? Marbles? How many ways can I do that? Technically 3, choose 3. Because of the 3 blue marbles, I have to select them all. Now there's only one way to do that. So if you want to write a 1, that's perfectly fine. But I'm emphasizing that we're choosing. It's the same thing we're doing here. I'm just choosing all the blue marbles. So let's have an example and see what I still need to do. All I have at the moment is the blue marbles floating around above my table. They're just floating, doing their thing. So I can't stress more, separate selection from arranging. If we're doing selection, let's finish that completely. Am I finished selecting my marbles? You say no, what still has to come? What?
Another marble.
Another marble? Okay. Another marble. How many ways can I choose that other marble? 12. 12? Let's go with 12, choose 1. But you're right, 12 is perfectly fine. Everyone happy with the 12? There's no restriction on what that other marble could be. So I can pull all the other marbles together. None of them are blue, I just select 1. So let's update my example. Now 4 marbles are floating around. Give me your favorite other marble.
Green.
Green? Which green?
Okay.
Second one? She has strong feelings about the second green marble. Okay, so now I have my collection of marbles. What do I need to do? Now I can arrange them. I have everything. How many ways can I arrange them? That's the easy step. 4 factorial. I have 4 things. I want to arrange them. Let's update. Let's say blue 1, green 2, blue 3, blue 2. And I've updated my example to the point where I have an arrangement of 4 marbles. That's what I'm looking for, so I know that I'm done. So 3 choose 3, 12 choose 1 times 4 factorial, and I'm done. But by separating the selection and the arranging, I can handle many restrictions even if the restrictions are different. Even if they say at this point, all the blue marbles should be together. That's a different restriction on the arranging than there were on the selecting. But by separating those steps, I can deal with whatever they have. In how many ways can I select a green marble? The phrase is a little unfortunate. We're looking for at least one green marble.
How come in C we didn't then choose the marbles?
We totally did. Here and here. Totally did. They were floating in the cloud because I chose them.
But in the previous one, the ones that were floating in the cloud in the beginning were just the cups.
That was different. It depends on the restriction. Here, my restriction refers to specific marbles. I need to have the 3 blue ones in there. The previous restriction didn't really refer to marbles. It referred to the colors. So I needed to get the colors correct. And then I could select the marbles appropriately. So my steps are very much decided by the actual restriction. So I want at least one green marble. Now we've seen previously that if I'm trying to do something that's at least or at most condition, there's more than one condition in here. When I say at least one green marble, it could be 1, it could be 2 green marbles, it could be 3 of them. And all of those three restrictions are in here. So if I say, let's call A the set of arrangements that they're looking for with at least one green marble. Let's visualize what is happening. So in my rectangle, I have all the possible arrangements of 4 marbles. In the circle, I have the ones I'm looking for, where there's always a green marble in my selection, in my arrangement, in my sequence. Maybe all green marbles, maybe just one, but they're all in the circle. How can I describe what kind of sequences are contained in A complement? He says no green marble. It's not entirely complete. It's the set of sequences that do not contain any green marbles. But we know what we mean by now. We know what we're looking for. We're looking for a sequence of 4 marbles, and the condition that A complement brings is there shouldn't be any green. No green marble. That seems to be much easier to count than 1, 2, or 3. I don't know which. So let's do the indirect approach and see how easy that is. Feels as if it's going to be okay. Actually, let me do it here. So the universal set, that is the no restriction phase. I'm trying to count how many ways can I do this with no restriction. Did we do that already? No, we did not. How many ways can I make a sequence of 4 marbles and there's no restriction? Even it's a good idea. Separate the selection from the arranging. How many ways can I select 4 marbles? What was this number? 15. And I need to select 4, and then I arrange them. Different ways to write that, but I think getting used to the selection, then arrange steps, it's a good idea. Now I want to think about the no green marble condition. Following similar steps, how many ways can I select marbles now? 12, choose 1? 4? 4, sorry, my hearing is first thing to go when you get home. Because I can't have the 3 green marbles, so I exclude them. I have 12 available and I need to grab 4 of them. Arranging? There's no restriction on the arranging. I've made sure that I do not select the green marble by saying 12, choose 4. My explanation is all in here. So I don't need to worry too much about arrows and explanation. It's all in here. I wrote all of this first to explain. This is my indirect approach. I understand what a complement means. Now I'll go to counting. Very important step to understand what the complement is given the set. So have a look at this. Try and get a feel for what's happening, and then we'll do the rest on Friday.